The way I would do this integral is just think about what it means to be something squared, and you can just square each piece. So I'm just rewriting the problem the way it was written, first like this, and then off to the side I'm thinking about doing some scratch work of what does it actually mean to be 1 plus r squared. Well, it means multiply by itself. So as you distribute each piece in there, I think it's pretty straightforward that you get 1r plus 1r is 2r plus r squared. And then the other thing is, instead of just dividing everything by r squared, you can divide each piece by r squared. Because think about if you're dividing you need the same denominator in order to combine them together. So I'm trying to just simplify this so that the integral makes a lot more sense. This would be 2 over r. I like to leave it like that, and you'll see why in a second, plus 1. Is when we go to take the derivative, so those are just some scratch work, you add 1 to your exponent and then multiply by the reciprocal of your new exponent. Now this one, if you were to leave this as r to the negative first and add 1, you would get to the 0, and then you'd be dividing by zeros undefined. So it makes sense then that there must be a different function that gives us that derivative. And that answer is 2 natural log of r. And you can double check that that's right. If you did the derivative of 2 natural log of r, you get that answer. The derivative of that, antiderivative of that is just r, and don't forget about plus c. Now I would rewrite this just kind of out of habit, like this. And don't forget, you need that plus c because the derivative of a constant is 0, and they're not going to write plus 0 up here. So this is a good answer.